Hello everyone. Today we're going to talk about the bacteria Faecalibacterium prausnitzii, and you may or may not call him, it, whatever you want to call it, the king of bacteria. But today, at least for today, for this video, I'm going to be referring to him as the king of bacteria, and you'll see why that's the case as we go along here. First of all, F. prausnitzii, many of you are familiar with it. That's probably why you clicked on this video. Makes up 5 to 15% of the total gut microbiome. I'm going to show you some results that are quite a bit higher than that. You might know that F. prausnitzii turns things like undigested dietary fibers into butyrate, that short-chain fatty acid that is so helpful for healing the colon, the colonocytes, and also produces other anti-inflammatory molecules. Now, we talk a lot about butyrate when we're discussing F. prausnitzii, and rightly so, but I think what gets overlooked a lot is this line: other anti-inflammatory molecules. All good bacteria, probiotic commensal bacteria, produce things that we call probiotics. Those are metabolites. That's what they actually produce, and then is in your body, and can circulate throughout your body. And today we're going to be talking about, yes, butyrate, but other anti-inflammatory molecules, because there are multiple postbiotics that good bacteria produce. So we want to focus on those as well. And the last pane there, butyrate maintains gut lining, combats inflammation. This creates a healthy environment for gut bacteria. I'm going to be referring to the colon, or that healthy environment, as the soil for your bacteria. And that is so true, that it creates a healthy environment, because that is absolutely essential. Now, a little more about this bacteria from Zoe Health and their PREDICT studies. PREDICT is what they call the world's largest in-depth nutritional research program. And the first phase, PREDICT 1 study, helped to define links between a person's diet, gut microbiome, and cardiometabolic health biomarkers from a cohort of 1,100 participants. So a very large number of participants. And they discovered, or they clarified for themselves what they think are the 15 best bacteria. So they would put crowns on all of these, and these are in no particular order, but you see at the very top there, F. prausnitzii. Second one, Bacterium elegans. We'll talk about that. That'll come up in a little bit. But just to see that from this study, F. prausnitzii is at least one of the kings, at least deserves to be, to use our analogy, in the royal family, as it were. Here's an interesting research paper. F. prausnitzii is an anti-inflammatory commensal bacterium identified by gut microbiota analysis of Crohn's disease patients. Now, this is all the way back from 2008. Normally, I try to get research papers a little bit more new than that. But this one is interesting because it's one of the 10 most cited studies in all of microbiome research. So that is significant. And here's what they found in regard to Crohn's disease and F. prausnitzii. We found that a reduction of a major member of Firmicutes, F. prausnitzii, is associated with a higher risk of post-operative recurrence of ileal Crohn's disease. In other words, post-surgery. Moreover, in vivo, that's within the body as opposed to in a laboratory, effects were associated with a decrease in pro-inflammatory colonic cytokine synthesis and with the induction of anti-inflammatory cytokine secretion. Counterbalancing dysbiosis using commensal bacterium F. prausnitzii as a candidate probiotic agent appears to be a promising strategy in Crohn's disease treatment. Well, as they refer to it as a probiotic agent, they don't mean necessarily probiotics that you take in capsule form, but that it itself is a probiotic agent. It's a probiotic bacteria. And what they're saying is the more F. prausnitzii you have, the better post-operative, post-surgery results, less likely for Crohn's disease to return or to be as evident. And again, that's because of the pro-inflammatory, anti-inflammatory effects of F. prausnitzii. We can also talk about the bacteria in terms of a keystone species. Now, a keystone, probably familiar, is that literally it's a key stone that fits at the top of a stone arch that for thousands of years they've been building bridges with this sort of technology. And a Keystone species is one on which other species in an ecosystem largely depend, such that if it were removed, the ecosystem would change drastically. I think we can say with confidence that our friend F. prausnitzii would be considered a keystone species, whether or not you call it the most important one in the microbiome. It's certainly, if it were removed, and if it were removed entirely, no doubt it would change the entire ecosystem in a dramatic way. So that's another way to think about this bacteria. Now, here are some results of how F. prausnitzii grows on various forms of HMO, human milk oligosaccharides. And we've got 4 different types there: 2FL, 3FL, 6SL, and LNT2. There are at least 150 different HMO types in human breast milk. 2FL is by far the most abundant of those. It makes up about a third. That changes over time for a nursing mother. But 2FL is by far the most abundant. And you see at the bottom of the key, the B. longum subspecies infantis, growing on these various types of HMO. And especially you can see it grows on the 2FL. Then you have the F. prausnitzii, which grows a little bit on the 6SL, on the LNT2, but really not at all on the 3FL or the 2FL. But the thing we want to focus on there is the co-culture. So this is culturing the B. longum infantis with the F. prausnitzii. And if you zoom in on that, you can see that the co-culture just skyrockets within 24 hours and then begins to level off. So even though the 2FL, which is in pure HMO from layer origin, that's pure 2FL, does not move the needle. The F. prausnitzii is not consuming that, is not benefiting from it. But if you have what the study is trying to demonstrate, if you have some bifidobacteria in your gut, then it can make a difference. Speaking of which, I want to walk you through 4 people that I've helped test. And each of these results are a result of consuming HMO alone. So in terms of there's no other soluble fibers, no other changes, appreciable changes that made to their diet or lifestyle during this before and after test. And each of these charts, as in normally with my videos, are from Biome Site. So we really appreciate the way they lay out the data points. And each of those, you can see when each person started taking the pure HMO. Now, this person was only on HMO for 5 weeks and had and actually started. This is the same person from my previous video. He started on HMO 2 weeks before the first test. So I should have put that in yellow. And so my guess is that his F. prausnitzii could have been even lower than 1%, but went from 1% to almost 6% in a short period, only 5 weeks. So, and again, that was only on HMO. Now, this person, in terms of the co-culturing with bifidobacteria, only has about 0.2% bifido. So that would not have helped the growth of F. prausnitzii, as far as I can understand. Second person had a good amount of F. prausnitzii already, and then over about essentially a single container of HMO, about 6.5, 7 weeks, went from about 14% to almost 20%. And this person has also very little bifido in their system. Third person went from 15% to almost 24%. And if I recall, this person does have bifido, about 4%. So that may have helped the larger increase as compared to the others. But again, all 4 of these were only taking HMO as a soluble fiber. And then lastly, this person also started with the most F. prausnitzii and went from about 17% to 22%, 23%. And this person only has, I think it was about 2%. So a little bit of bifido. That's quite a bit compared to most adults. So those are the results that I found from, again, it's just anecdotal, but it's 4 people, and they all saw significant increases in their F. prausnitzii after consuming HMO. Now, here is my butyrate progression over time. You can see it started about 52% all the way up to 77%. And that's it's an extremely high number. That puts me in the 100th percentile. You can see it's literally off of the chart there. But at 77%, most people say, and again, let me remind you that this number 77% represents the number of butyrate producing bacteria in your gut. So in my case, when I took the last 16S test, my 77% of my bacteria in my colon were butyrate producers of some kind. But part of what happened is when I was at 65%, which I was very happy with, I made a change in my diet, and my bifido actually crashed from about 8% to 1% recently. And I think I have a handle on that, and I might make a video about that in the near future. But I would rather be personally at about 65%. I'd rather go back to where I was in that regard, 65% butyrate and almost 8% bifido, as opposed to 77% butyrate producers and only 1% bifido. So those are some changes I'd like to see. But also want to point out that just because you have a high level of butyrate producers doesn't mean you're producing a lot of butyrate, because not all butyrate producers are the same. Quite a bit of difference between them. So let's talk about that. From this source, the most abundant butyrate producing species detected in recent 16S gene studies of adults are F. prausnitzii, U. bacterium rectale, U. bacterium hallei, and Anaerobic hadrus. And these are my top 9 species, not just my top 9 butyrate species, but the top 9 species in my gut from Ombre. And you can see at the very top there, F. prausnitzii and U. bacterium rectale. So the 2 of the 4 that's listed there. One of the 4 that is not listed from this source, but we know is a really great butyrate producer, is the Roseburia intestinalis. And let's talk about that for a minute, and a couple of these others. This is a chart, a study showing the various butyrate producers and how much butyrate they produced in the laboratory based upon consumption of various things like glucose, phos, XOS, so that's xylo oligosaccharide, fructo oligosaccharide. And if you zoom in there, you can see, actually, look at F. prausnitzii on the right there, and then all the way to the left is the Roseburia intestinalis, which I just mentioned. And there in the middle is the Anaerobic hadrus. So it would appear, at least from this one study, that Roseburia intestinalis is the king. Again, at least from this one study in the laboratory producing butyrate. But they're all good top butyrate producers. Now, I like to think of my diet, what I'm trying to do with my gut health. I've never heard this term before. It may be out there, but I coined the term for myself, gut farmer diet. And I refer to this as feeding and seeding your gut through diet, prebiotics and probiotics in order to produce healthy postbiotics. So let's talk through that a little bit. So prebiotics, they are food for beneficial bacteria. So it begins with your diet, always begins with your diet. And I ascribe to the fiber fueled diet or something close to that, where my wife and I aim at 30 different plants in a week. If we strive for that, we know that we're getting a good variety, a good amount of colors and different nutrients. For example, when I'm done with this video, I'm going to eat lunch, and it's got 10 different plants and seeds and legumes in it. So eat that most days. Soluble fibers, already mentioned the oligosaccharides and HMO, human milk oligosaccharide. Soluble fibers that your body, your colon, cannot digest whatsoever. It is meant for your bacteria. It literally feeds them and them only. And polyphenols and other things. Anything that will feed beneficial bacteria. Now, your food, your diet can also feed bad bacteria. And you eat a high sugar diet, the standard American diet, and that's going to feed the bad bacteria. So you're always, everybody is a gut farmer. The question is, are you a good gut farmer or a bad gut farmer in terms of what it's producing? So that's the prebiotics. Probiotics are essentially live beneficial bacteria. And of course, that is what you're aiming for in your gut, in your colon, in your gut. But we can take these in probiotics in through things like fermented food. So we eat kimchi, we make our own kefir, I make my own kombucha, make my own yogurt. So you can take in probiotics through fermented foods, through probiotic capsules, which everyone hears about, and trying to get the latest and greatest probiotic capsule. Personally, probiotic capsules have never moved the needle for me. Interestingly, it's this bifido yogurt that I've made recently that I believe is the thing that ultimately, oddly enough, I was trying to, I was greedy. I had 8% bifido and I wanted more. And I was trying to get more, and it ended up unintentionally, I believe, is part of what crashed my bifido. So I was going to say I've never seen probiotics change my gut result very much, but in this case, I believe it did. But I think I'm going to be able to rebound that, and again, I'll probably make another video about that. So prebiotics, probiotics, and then collectively those produce postbiotics, which are the metabolites of bacteria. I already mentioned the short-chain fatty acids, including butyrate, anti-inflammatory molecules, neurochemicals, serotonin, GABA, those sorts of things, all are postbiotics. And this is why you want to have these good probiotics in your gut. Ultimately, what you're aiming for is not just happy bacteria, but happy, good bacteria that produce healthy, beneficial postbiotics for you. Now, the middle diagram there representing obviously your colon is what I would call the soil. That's where that is, if you were an actual farmer and you had a garden, that would be the soil out in your garden. And just as, anybody, an organic farmer, anybody that has a good garden, we all understand that beneficial plants, good, healthy plants actually put nutrients back into the soil. They take nutrients from the soil and put good nutrients back into the soil. So just as in regular farming, when you have a good, healthy gut, it's a two-way process. The good bacteria are actually helping the soil be better. Again, one of the postbiotics of butyrate helps heal the colon and heal the colonocytes and close those tight junctions, which is a leaky gut. So all of it just works together in wonderful harmony. It's just absolutely amazing. So the result is that prebiotics plus probiotics will then lead to postbiotics. And as a general rule of thumb, you want to, in terms of postbiotics, you want to go for the highest yield and also the highest quality of these postbiotics. So taking this a step further, when talking about the production of butyrate as a postbiotic, and for this illustration, I'm going to talk about 3 different fields of corn. You've got field A, B, and C, and they all have 1,000 stalks of corn. So you'd think, well, they're all going to produce about the same amount of corn, correct? Well, under normal circumstances, they would. An average stalk of corn has usually 1 ear of corn, sometimes 2. But for this example, I'm going to say they have 1 ear, 5 ears, or 10 ears. Now, obviously, if that was the case, your yield, your final result, is going to be drastically different between 1,000 or 10,000 ears of corn. Now, obviously, if you're farming, you want the highest yield. And if you're gut farming, you want the highest yield. And in this illustration, bacteria like F. prausnitzii and the Rosebury intestinalis, those sorts of bugs, are the highest butyrate producers. But you have other butyrate producers that technically produce butyrate, like Glaucia, and I've got a lot of that. I've got to think about 15% Glaucia. So out of that 77%, 15% of my butyrate producers aren't producing a lot of butyrate. They are low yield butyrate producers, which is why bacteria like F. prausnitzii are more the kings and queens of the butyrate producers. And those are the ones you want to aim at. And those are the ones you want to sort of, quote unquote, count a little bit more as you're looking at your gut results. A couple more research papers: impact of 2FL on gut microbiota composition in adults with chronic gastrointestinal conditions. In a subsequent open-label pilot trial, the effect of 2FL containing nutritional formula was evaluated in 12 adults with IBS or ulcerative colitis. Gastrointestinal quality of life index, total and gastrointestinal symptoms, domain score, stool counts of bifidobacterium and F. prausnitzii in stool short-chain fatty acids, including butyrate, after 6 weeks of intervention. All that is to say, here is a result. Consumption of the 2FL containing nutritional formula by adults with IBS or ulcerative colitis was associated with improvements in intra and extra-intestinal symptoms and bifidogenic and butyrogenic effects. In other words, consuming 2FL increased both your levels of bifidobacterium and your levels of butyrate-producing bacteria. So again, back to that previous graph of the bifido and F. prausnitzii in a co-culture along with 2FL. Well, this is just another study demonstrating the same result. You get dual benefits of bifidobacteria and butyrate. Now, of course, this is one study. It's not going to happen for everybody, but it can be true for many. And then finally, this is a fascinating study, which gives a different benefit that we haven't talked about F. prausnitzii. It's a functional metabolic map of F. prausnitzii. Now here we have sialic acid is an amino sugar found in human mucus and thus extensively present in the human intestine. Obviously, inside your colon, you've got the single layer of colonocytes and then a layer of mucus that's also protective in there. Sialic acid utilization confers a competitive advantage to several pathogens and opportunistic pathogens colonizing the gut, including Salmonella enterica, Bacteroides fragilis, and enterohemorrhagic E. coli. So all of these pathogens, what it's saying is consuming the sialic acid that's found in the mucus already in your gut, and it helps them to grow. But here's another benefit of F. prausnitzii. F. prausnitzii is one of the few human gut commensals possessing the sialic acid utilization gene cluster. So in other words, it's one of the few bacteria that can also consume and grow from the sialic acid in your mucus, in your colon. So the microbe's ability to utilize sialic acid may be beneficial for the host if it can successfully outcompete pathogens in mucus-rich environments. Now, why is that important? Well, we've already talked about the butyrate production from F. prausnitzii and all of the multiple possible metabolites and probiotics that can come from it. But in this case, you see the competition that's happening. And this is one of the amazing things of a healthy microbiome. As a general rule, the more healthy bacteria you get, the more the unhealthy LPS producing gram-negative bacteria that produce toxins and travel throughout your body can cause all manner of disease, autoimmune disease, etc. The more healthy bacteria you get, the more it sort of pushes out or outcompetes, wins over the soil and produces more of the healthy bacteria. And unlike my prior illustration where I had 3 fields of corn, we don't have an unlimited number of fields. We've only got 1 field in your gut, and the bacteria are constantly competing. So in this case, the F. prausnitzii can outcompete. It's a way that it can outgrow the pathogenic bacteria in your gut. And I've seen that again with all manner of the soluble fibers, but in particular, HMO outcompetes pretty much everyone that I've helped test. Their gram-negative bacteria plummets, and their gram-positive bacteria, including the butyrate producers, really do skyrocket. So that's yet another of the many benefits of F. prausnitzii, which is why, at least for today, I have called it the king. I'd love to hear your feedback on that, but I think you would agree that it's a very, very important bacteria, and I hope that you're growing a lot of it in the soil as a gut farmer, and I hope this has been helpful for you.